Welcome to Theory of Computation. Today I am going to give an introduction about a polynomial time reduction. So what is the definition for this PTR means? A transformation of one problem to another problem without changing its significance at runtime. That means that for a particular problem P1, I try to find a solution for this one, and for the same problem I get a solution as P2. If the answers are same, then I can able to say that P1 problem can be reduced to P2. So this is the time reduction. So consider if L1, L2 are two non-polynomial problems. So non-polynomial problems means at a particular, so it is two category. If you able to find a solution at particular situation, then that problem is called as NP complete problems. If there is no solution for that problem on all situation, means those problems are called as NP hard problems. So I don't know whether L1, L2 are comes under NP complete or NP hard. So we assume that these two problems are two non-polynomial problems. So if L1 is a polynomial reduction to L2 with some conditions, then L1 should be NP complete. So in which situation the problem P1 can be reduced to P2? If P1 has a solution and P2 also has a solution, then we can able to reduce P1 to P2. So like that, if L1 is reduced to L2 means we can able to find a solution for L1. So L1 should be NP complete. So in which situation you can say that NP complete? At any particular condition, if we try to find a solution for NP problems, then those problems are considered as NP complete. So based upon the definition of NP complete, if you say that L1 is polynomially reduced to L2, then L1 should be NP complete. So if L1 is NP complete, then L2 will also an NP complete method. So this is a polynomial time reduction concept. So we can able to say that L dash is a polynomial time reduction to L with a time bounded Turing machine with that Turing machine takes input as X and it will produce an output as Y. So L is a polynomial reduction if and only if the same input X is used in L dash. So if L dash be a polynomial time reduction to L, then there are two possibilities are there. One is if you consider L is NP complete, then L dash is also NP complete. If you take L is a non-polynomial or an undecidable problem, L dash is also considered as an undecidable problem. So this is the polynomial time reduction, in which I am taking an example of traveling salesman problem. What is the basic concept behind traveling salesman problem? Means in a non-linear data structure, consider it is a graph, it is a weighted graph in which all the nodes are visited with some edges are there. The basic idea of traveling salesman problem means we should start from the source node and the travel should be ended with the destination node. Then you should visit all the intermediate nodes with minimum edges. So I want to trace all the edges from source to destination and there is no closed path representation. So this is the traveling salesman problem. So how can we implement this concept? So there are three different conditions are there. First condition is we should visit all the edges of a graph at least that means exactly only one time. So if you go to the node 2 from 1, so 1 will be considered as a visited node and 2 will be also be considered as visited node. And at no situation you cannot able to visit the node 2 at second time or third time. That is wrong. So you should visit all the nodes in a graph only once. This is condition number 1. And condition 2, it should complete all the vertex as a cycle. So at last there should be a cycle for completion of all the edges in a particular graph. So this is the second condition. And third condition, it can be solved by checking a Hamilton circuit in a given graph. So what is the Hamilton circuit means? A set of edges with only single cycle. So all nodes are connected with only a single cycle, and each node should appear only once, means that circuit is called as Hamilton circuit. And another condition for Hamilton circuit is if you draw a Hamilton circuit, in that the number of nodes and number of edges should be equal. So if you consider this graph, there are 4 nodes are available, namely 1, 2, 3, 4. If I want to draw a Hamilton circuit, the only one Hamilton circuit is 1 to 2, 2 to 4, 4 to 3 and 3 to 1. This is a Hamilton circuit. So if you consider this circuit, so this is called as Hamilton circuit, in which the number of nodes are 4 and the number of edges are 1 to 2, 1, 2 to 4, 2, 4 to 3, 3, 3 to 1, 4. So number of edges are 4. So if this condition is satisfied, this is called as Hamilton circuit. So I want to check whether any Hamilton circuit is available. So if you consider the whole traveling salesman problem, it is considered as NP problem. Instead of that, this problem is reduced to finding a Hamilton circuit in a graph. So if I am considering the one problem as another problem, so it is a polynomial time reduction. So polynomially reduced notation, and in this Hamilton circuit, I want to check whether the graph contains a Hamilton circuit or not. If any possibility of forming a Hamilton circuit, then there is a solution for finding the traveling salesman problem. Okay. So the implementation of this NP complete, so it will be considered as, if you consider a traveling salesman problem individually, it is a non-polynomial problem. Instead of that, I reduce the problem as finding a Hamilton circuit. So this is called as NP complete problem. For implementing the Turing machine, we should go for a non-deterministic Turing machine. So using the non-deterministic Turing machine in a multi-tape format, only we can able to find a solution. So already given the implementation of multi-tape Turing machine in a Kruskal's algorithm. So the same concept is applied for finding the traveling salesman problem solution. So here also I want to implement the graph in a 3 input notation. One is the Turing machine and the number of nodes and the maximum distances. So if you take a Hamilton circuit, the length of the circuit is 15 plus 20 plus 18 plus 10. So it is 30, 60, 63. So instead of that integer value, I want to convert it into binary representation, and you should write the path. That is the possible paths are 1 to 2, 2 to 4, 4 to 3, 3 to 1 and 2 to 3. There are 5 edges are available and its corresponding distances. So 15, 20, 18, 10 and 12. So all these values are separated with the single parameter. So totally 3 parameters values are available. One is the source node and another one is the destination node and the edge. So these values are converted into binary notations, and we should implement and test whether it satisfies the maximum edge as 63. So the machine either it will give yes input, otherwise it will give no representations. So in this way we can implement the same notation for finding the traveling salesman problem. So this is the way of introduction about polynomial time reduction concept. So the main problem is for finding the solution for traveling salesman problem, but the problem will be considered as a non-polynomial problem. So instead of that, I am taking a sub-problem from it TSP. That means for finding a Hamilton circuit in a given graph. So I reduce a problem into another type of problem, that is a Hamilton circuit, to find out. That solution will be treated as NP-complete. A Turing machine can also able to solve an NP-complete problem with the help of non-deterministic Turing machine. So in this way, a same Turing machine can able to solve both tractable and non-tractable problems. So thank you.